everyone, and welcome to the BCS DevSecOps Special Interest Group. Great to see some people here in person, which is great. So it's our second meeting of the season where we've actually had people along in person, so it's great. Hopefully some more people will be able to come to London and do that. But the reason we're running meetings in hybrid mode is because we do appreciate not everyone's able to do that or wants to do that, and that's absolutely fine. So for the future, for the foreseeable future, we will continue to run meetings like this, and please spread around, in a room. That's the idea where we've got lots of chairs so that people can feel really comfortable about being here. So that's great. So welcome everyone. Last month we had a really interesting talk about application security, and that was really good. So we've now got a talk this evening, and we're going to be looking at the world of containers and how that fits in with development and life cycles, DevSecOps, and a little bit about Kubernetes. So I'll just introduce Matt. So if you come along here. So Matt's a colleague who I work with at IBM. He'll explain a little bit about himself, but he's going to tell us a little bit about container world and Kubernetes and security as applied to the development, life cycle. So please, I'm sure you're happy to take questions as we go through. Please do that. It makes it much more interactive, and then you won't get your questions lost. And we want to make sure that we're answering the points that you would like to ask. If you're listening remotely, put your questions into the chat. I'll monitor the chat and pick up the questions at an appropriate point, and we'll go away. Yep. So thank you very much.
All right. Hi everybody. So as Will said, I'm going to be talking about Kubernetes and containers and security related to them. So first of all, to introduce myself, I'm Matt Coleman. I work for IBM. Been with IBM for 30 years, I think it is now. My background is working with infrastructure and platforms, then moved to cloud, and then recently moved over into the security world for the last few years. And my focus has been around looking at both cloud security and also container security on top of that. So what's interested me is that I can absolutely see the benefits of taking containers forward, but I'm fully aware that there are security concerns around it, security considerations. So that's one of the things that I'm keen to help others understand. That's what I've been looking into, building up knowledge around that area. And I don't know whether anybody else finds this, but my family, my wife knows and appreciates that I work with cloud security and does something around that. And my kids are just aware that really I work out a lot of this in IBM at the moment, but one day hopefully they'll have a comprehension of it.
So to send the audio, it's not that. So, maybe I'll wait, just speak up a bit. I'll just check.
Apparently my audio is rubbish. Get that proved up.
He's going to get a mic. We want people back here.
Yeah.
It's security. You don't know anybody here.
So do you want to just
I'm just picking up off. Where is it?
Hopefully, let's see. Right, is that better?
So you need to hold it quite close.
Right, okay. Probably have confirmation that's any better from people on the line.
So Frederick says thanks.
Right, okay, cool. Right, so in terms of the agenda, what we're going to have a look through today, as was shared on the invite, we're going to be looking at containers, the role of Kubernetes, looking at security concerns around those, and then understanding the role that security plays across the life cycle and into runtime when it comes to creating containers. Okay, so the first thing we'll do then is I'll try and fill you in a little bit as to what a container actually is and where Kubernetes comes into play before then tackling the core part of this, which is really focused around security. So I'm not the most technical person in the world, so I'm sure if you are fully appreciative of how operating systems work, you can probably trust my knowledge on it. But anyway, I'll make an attempt at explaining how this is all possible. So the key thing to make sure that we understand here is how containers can come about. And so there are some features available within Linux here, and obviously we can also run Windows containers as well now. But we're focusing around Linux and how containers are possible. There's two features within Linux. And one is namespaces, and that's where we can isolate processes within the kernel, and we can make them invisible to each other. And then we've also got this thing called control groups, the C groups. And that's where we can actually control for those processes or set of processes the resource they have access to, and the resource will be CPU, memory, disk I/O, etc., etc. So we can have that isolation, and this forms the bedrock of how containers can come about and can be run on an operating system. So now that we understand how it's possible, the next thing to do is to actually try and at a high level think about what a container is. So a container is your application plus all of its dependencies packaged up into a software unit that you will then have portability to take wherever you need it to. So by packaging up the dependencies that that application requires, you can then take that from one operating system, so from one instance of Linux to another, and it will run because it's got everything it needs and uses the underlying Linux kernel for everything else. Now, a container image is a read-only instance. Effectively, that is the packaging up of your application and its dependencies into a read-only entity, and then when we spin up into a runtime, that is the container. And at that point, there's a writable layer added to the container and so on. But that's where we get that. So you've got the images and you've got the containers. So in terms of how we can build a container, so generally the way that containers are created at the moment is using a Docker file. In process of some locations being renamed to a container file, that's due to the fact that Docker as a company is therefore not a vendor neutral term. So you can use either, you'll see that, but fully appreciate they are pretty much identical. They are the same thing, they're a representation of the same thing. So we can then create that configuration file. And in that configuration file, we're going to specify something called a base image. And that's where our container, what our container is going to be based on. So that base image might be something like Ubuntu, might be something like Red Hat, might be any operating system. But you might also find that you can actually use something somebody else has already packaged up. So they might, for example, decide they're going to build something on Red Hat, they're going to add some additional packages into it, they're going to add their application, and then you can take that and use that as your base container. So for example, on projects that I've worked on, we can go and get an Nginx container, and that Nginx container is built on an operating system with Nginx packaged up onto it. And we can use that as our base if we wanted to, and then make our changes on top of that. So in terms of actually building a container, you're going to need to use a tool to do that. Our popular one of the most well-known ones is going to be Docker, but there's also tools like Builder and Canico available as well. And they're just different ways of converting that configuration file into a container image, which you can then put into a runtime. One of the things that you've got to be aware of, and this is both from a security point of view, but also from a good practice point of view, that you want to be careful around the size of the containers that you're creating. And the reason to be aware of the size and be careful of the size is due to the way that some of these technologies actually construct a container. So if you're using Docker, it will build layers. It uses a union file system to basically say every time you're going to run a command on this, you're going to say, start with your base image, run a command to add a file, delete a file, change a file, whatever it might be. That's going to be added as a layer. And that layer has size to it. So even if you were to create numerous layers, you add a file, and then by the end of it, you've deleted it, it's still got to take the size of that file across all of those layers together. And so you can end up then actually really bloating an image and end up with containers that are then potentially gigabytes in size that you're going to try and move around, whereas you can actually restrict the size of it. So one of the things that you can do, and it's available in tools such as Builder and Canico, and I think there are extensions you can use with Docker here, is you can actually look to flatten those layers, or you can take a snapshot of the image, which means you can press all those layers together, you don't have to worry about those different sizes. So something to just be aware of there. From a security point of view, it's also good to make sure your images aren't like the things they don't need. And then when you've created that image, it's going to be stored on your machine, and at some point you're going to want to push it ideally to a remote repository where it can be stored in there, and then others, if you want to give them permission to have access to that image, we're going to be sharing like that. So we now know how containers are possible, what container images are, how we can go about building these things. So next we need to think about how do we actually then run the container, the runtime implementation of this. So when you're looking to run a container, you've got to use a container runtime engine. So the way that you can see from the image here is that it sits between the host system and containers, and what that container runtime is doing, doing is to effectively abstract for us all of the necessary interactions that need to take place to spin up this container. So where you could type in the commands and say, I want these namespaces, I want these secrets, I want to do all this, the container engine is going to do that on your behalf. You just say, I want a container, it knows how to make it. So that does that abstraction for us, and there's a number of ones available. The common one used now in later versions of Kubernetes is Cryo, and Containerd is the technology sat behind the name of Docker. That in older versions of Kubernetes was what was used, but they've now moved away from that as of recent versions. It's all to do with compatibility and open spaces and things like that. But that's where it's seen a shift. So nowadays, if you're going to deploy Kubernetes, you get to choose which of those runtime engines you want, and you're not limited to just using Docker. So then we can think about what is the need for container orchestration. We can spin up containers, so why do I need to go any further? What is the actual use case for it? And it's all to do with the managing of containers at scale. It's managing, it's scaling them, it's automating deployments, it's taking that one step further. So where on my machine I could say, I want to run a container, and let's assume in this case I'm using Docker, I could say I want that container based, but what happens when that container dies? It doesn't need to be replaced, it just had a problem and it died. But in an enterprise system or a system at scale, you're going to want something that can recover that for you. So what you want to do is say, I always want to have one of these containers. If it dies, spin me up a new one. So you can manage that. You can also manage the scale. You can say the number of replicas you want. You can decide where you're going to position it. You can tell it how you want it to orchestrate and look after all of your containers that you're running together. Again, if you think about running a full system of these things, you potentially are having a lot of containers, not just at that scale of running one to a machine, but you might want to manage them a bit more locally. So we have to think about that. And that's where the orchestration comes in. You can run at scale and you can run thousands of pods across these things, thousands of containers. But we have common security challenges here. And the reason why we have these challenges is because containers are innately not as secure as running a virtual machine. That is the common thing that you will hear. Somebody says, well, for the virtual machine, I've got isolation. I'm running it inside a hypervisor. I've got my own kernel. I've got my own operating system. I would have to break out of my virtual machine through the hypervisor and try and get into another one. The difference is for containers is that you're just running processes on the same underlying kernel. So if you can get out of your container into the underlying host, you potentially then can try and access the other containers that are running on the same host alongside it. So you've got the security concern there. And the reason is that containers didn't come about with security in mind. It wasn't at the forefront of why they were trying to do things with containers to enable a different way of working. Now, the orchestration element as well isn't by default built to lock everything down. The idea again behind Kubernetes is to support the running of all of these pods, these containers around your estate. So things aren't locked down by default. We just need to be aware, though, is that we naturally will need to get involved and make security happen around our running of containers. And another key thing to think about as well is having that in mind and thinking and using orchestrators here is everyone wants to take shortcuts to make life easier. We have to bear in mind that's how people want to work. So, for example, I want to get something running on Kubernetes. Do I want to have to worry about 5 layers of security to allow myself to run it on there? No, if I can take a shortcut, I'll type these settings in and I'll spin something up and run it. The problem is that later in the day, when you do need to lock things down, you then potentially made a rule for your own back because something might now not work when you did bother looking things out. So we've got to get that balance right. We've got to help educate people, and that's a key part of this. So in summary of this part here, I've told you how containers are possible, giving you a bit of information around what container images versus a container in runtime, how they use a runtime engine to abstract and allow that technology to be feasible, why the orchestrator comes into play, and the fact that there are security challenges that we've got to be conscious of. So this is then the meaty section. This is where all the security stuff comes into play, and there's lots to try and cover. And I think I have changed this section around in terms of the order of the slides and constantly slides numerous times to try and make sure everything is there. It won't be exhaustive. I'm sure if you know about a particular area of security in there, you may find something that I missed off. Absolutely happy to be told that's been missed off, and that's fine. I've tried to include an all-encompassing message around all of the stuff, but there is a lot that can be done. There's a lot to be understood. So, first of all, when I was thinking about this, I was trying to demonstrate clearly, and hopefully this does it, we have to think about security across every single phase of a development lifecycle here. So all the way from planning and thinking about what we're going to do to actually then running it, we will need to put security in those phases. And so what I then try and do over the next few slides is to show a bit of alignment to the phases, but bearing in mind that for everything that I'm going to show you here, it's applicable across all phases, just some things you might want to think about front in the planning phase and so on. So this I thought again was another thing to have available and demonstrate the importance of it. I'm finding myself in lots of conversations with clients, with colleagues, trying to learn about container security, and generally everybody will listen to me babble about containers and have a chat about them. There's some key things to be doing here, and we'll touch upon them in detail, and some of these are guided by the white papers that are out there around security. But we've got to make sure that we're thinking about securing the container that we're creating. We've got a security orchestrator. We've got to be looking at the runtime and make sure that we are happy with the security there. But the key one that I then added to the top of the list was, well, actually, when you've got the security knowledge around it, one of the key things really is going to be people focused. We've got to tell people, we've got to help people actually think, again, thinking about the planning side of things. This is all the security that is available to us. This is what can be done. If you think about it up front, you can actually make your container system incredibly secure. There are lots of things out there. It's not like it's a case of throw it and hope that it's going to land and it's going to be all right. Actually, there are lots of things there for us to use to make our deployments highly secure. So I would say placing yourselves in with those development teams, working alongside them, placing yourself in with the engineers, with the security engineers, and actually sharing this knowledge and sharing this information is a really key thing as well. Okay, so like I say, I've tried to align some of these with some of the phases, but again, they're across the life cycle. But this is where I would say you want to be thinking about these things. So, for example, this paper here, if you haven't read it, if you're interested in container security, go and have a read. Okay. So it's the NIST special publication 800-190 application container security guide. And the useful thing in there is it breaks down into 5 clear areas where there are areas of risk around running containers, and I'll touch on that later. And it gives you some countermeasures, it gives you some examples. It's just a useful paper to make sure that you have a read through of at least once if it's your area that you're focused on. Recently, the NSA and the CISA have created a Kubernetes hardening guide. So this is another one. If you're going down the route of actually wanting to do hardening, you would want to have a read of this. Alongside this, there's also the CIS Kubernetes benchmark. It's 1.6 now, something like that. Again, those are reference points for you, things to have a look at, things to get an understanding. And the stuff that I will be talking about in here, you will find in those materials. If any, it's not like it's a secret on all this stuff I'm telling you here, nobody's thought about. I read all these things, which is why I'm then trying to share some of this information back with you guys as well. So hopefully we'll get that through. Okay, so here is this container security here. So that black box that you see down the side, image registry, orchestration, hosts, and the containers. Those are the common risk areas called out in this publication. Okay, and that's where they will then give you countermeasures based around those risk areas. But the interesting thing is to then place those on the model on the right-hand side. Again, across those lifecycle phases effectively, so build, ship, and run, is where those things are going to play a role in that part. Now, it's all very well that you can say, right, well, host OS and orchestrations on the right-hand side of the screen, it's the last thing to think about. Well, actually, that's probably one of the first things you're going to think about, because that's actually how you're going to put your orchestrator into action. If you haven't got a machine to run it on, you haven't thought about your configuration, what you can spin up. So that's why I then thought, right, that's the bit that I'll start talking about first. So the host OS is an area of security to consider because of the way that you can, because of how you can effectively run your host OS. So you could decide, I'm going to use a full-blown operating system here to run this. My immediate question, if I was sat in a room with somebody and told me I want to do that, is, can you tell me why you want to do that? Because you don't need it. Okay. There are container optimized distributions out there, Flatcars one, you've got CoreOS, now Red Hat CoreOS as examples. They are specifically built with running containers and orchestration in mind. So, like saying, well, no. And an analogy would be, you're a farmer, do you want to drive around in a Ford Fiesta ploughing your field, or do you want to use a tractor? Yeah, go and choose the right thing. They built something for the job, so go and have a think about what you use. And as I've set out on the slide here, the benefits of using that minimized, that container-focused image is that it's minimal, so they've only included what they need to actually run in containers, so you're not bloating it, you haven't got those things to worry about patching. It's immutable, so people aren't going to be able to install stuff on this. Again, that's a really key thing. Moving towards cloud, ideally, everything that you can do, you're moving towards immutability. This is just another example. So we're obviously being part of IBM, Red Hat being acquired by IBM, I've therefore had interactions with OpenShift, with CoreOS, and so on. So that's my kind of viewpoint of the world, but I'm fully aware there are others, and I'm not here to tell you one product is better than another. But having had a look at the CoreOS side of things and having to dig into the security for the projects that I'm on, it's understanding how only part of the file system, where things are actually installed is read-only. So, for example, you can't get rid of do stuff. They don't provide SSH access to it. It's locked down, it's immutable. They do atomic upgrades. So there are partitions. You're going to do the upgrade. If it works, it works. If it doesn't, it rolls back, but it's not going to mess around with the rest of the machine. And then you flip partitions when you need to reboot and reboot into the updated version. So you've got that lovely kind of control area around this and minimizing your security risk. Whereas again, having a conversation, somebody tells me it's a full-blown OS, I'm going to be saying, well, first of all, consider why you're using it. Okay, let's say you give me a legitimate reason for using it. Right, well, get rid of everything that you don't need. You don't want to be having to look after things on it that don't need to be looked after. So remove that. And then absolutely perform hardening on this. Go and find the relevant baseline for the operating system you're running and harden it to within an inch of its life to make sure that it is as secure as it possibly can be for what you're then intending to use it for. So with the host OS out of the way, we can then look at the orchestration, the orchestrator. Lots of items here, and I will look to cover these as we go through the next slides here. So, although I say Kubernetes isn't security focused, it has lots of things for security that are just not all implemented on day one to lock everything down for you. Excuse me, you've got to go and use these things. Okay, so if we're thinking about how we're going to make sure that we've got a good configuration of our orchestrator, go and look for a benchmark. There's one, so CIS Kubernetes benchmark here, covers the areas around the control plane, around the data storage, around workloads, etc. Utilize that. So right, I'm going to actually configure this once I've installed it. I'm then actually going to make sure the right things are locked down. And here is some good quality guidance that I can rely on. It tells me how things should be set up in a secure way. So having done that, one of the things to also make sure you're thinking about is the accounts that are set up within Kubernetes. So Kubernetes has the concept of a human user and a service account, which is the programmatic equivalent. So when you're running things within Kubernetes, you will spin up things called pods. And pods can contain one or more containers. So that's the relationship there. So when I'm talking about Kubernetes, you'll probably hear me talk about containers or pods, because really I use them interchangeably, but I'm sure it would be strict on how I talk about it. But anyway, so you're going to have human access, and we need to control that, and we need to think about how we're doing that. But we also need to think about the programmatic access, and we can control that in Kubernetes as well. So we've got service accounts here, and so pods that are running within the cluster can be given permission to interact with the API, and by doing that, they would have to do that under the permissions granted to the service accounts associated with them. So you need to think about what permissions do I need. What do I want to assign to the service account? How do I want to control that access, as well as the humans that are interacting with this cluster? This diagram here, you'll find that I think I redrew a Kubernetes own diagram here, so it'll look very similar to that one. It was just I needed to redraw it for something I was working on, so I've used this one since. So this really nicely, for me, demonstrates the process that any interaction with the Kubernetes API server goes through. So whether you're a human user, whether you're a service account, initially you are going to go through authentication, assuming you have authenticated. Kubernetes doesn't have an inbuilt authentication mechanism. Kubernetes relies on an external identity provider. So you can tell it you are going to use this identity provider, and that is how you will achieve authentication, but it's not built into the actual Kubernetes mechanism itself. So you go through your authentication. You've done that, you'll present your credentials in one way or another, whether it's certificates, tokens, username, password. And then beyond that, you then go through authorization. Now, this is achieved within Kubernetes via RBAC. So you will have against your user or against the group that you reside in a set of permissions that have been attributed to that. And then once you've gone through those two stages, we then have permission control. So the authorization is actually looking at the verb that you're using effectively. So it's going to check who you are and on what verb you're using. So for example, do I want to get, describe, do I want to create, do I want to delete? Should I be allowed to do that being who I am? What admission control does, you've just jumped ahead, Frederick, I will just answer that. So in terms of what admission control does, this is actually looking at the contents of what you are trying to change. Now, the way that I describe this in conversations with people, I've probably got to find a more politically correct way of doing it. But I always say it's like the bouncer on the nightclub door. If you turn up and you're wearing your trainers instead of your smart shoes, and their policy is only to let you wear the right shoes, the admission controller, the bouncer is the one that's going to tell you on your bike off you go. Okay. So it's actually looking at, it's making decisions based on policies effectively. And there are many different admission controllers and they handle their policies, whatever you want to name them, different ways. Refer to them as policies here for ease of conversation. And I'll touch upon some of the key security ones, but this is actually looking at the configuration changes you are trying to apply. Okay. And then assuming you get through all of that, you'll then have your changes persisted to the data store, which for Kubernetes is TCD. Okay, obviously, if you are just requesting new stuff, you're not trying to persist changes, but let's assume that you were trying to make a change to the cluster configuration. Hopefully, Frederick, that answers your question. If not, let me know and I'll have another go.
And excuse me, the items that are hiding behind the
Yes.
person's names, are those
Have you minimized the
databases?
black? Maybe.
Are those databases?
That is the data store, yes, that's the DCD, yeah, distributed data store.
Yes, I think you can push the little single bar icon, is that work?
Oh, well, I've just done it on my screen.
Oh, it's not showing on yours.
That's not.
Oh, I see.
No, but it isn't moving it around.
It's probably,
I am moving it around the screen. It's not. Yes, so that's representing data store, and that's part of Kubernetes. Okay, so as I mentioned, roles-based access control permissions will be assigned to some default roles within Kubernetes. So these ones come out of the box, but you can create your own. I'm going to try and move that. That's the one. There we go. Thank you. So within Kubernetes, we have a concept of cluster roles and cluster role bindings and role binding. And so a role will determine resources and permissions that you have over them, and then a role binding will tie that to a user or a group and potentially namespaces as well. Now, appreciate namespaces was mentioned on one of the beginning slides when it comes to Linux. This is a different type of namespace.
Google.
I would Google that one, Frederick, but I have provided a few links to the back of this presentation, but not necessarily that one. I can't remember. If I haven't, it is widely available, so yeah, give it a Google. Right, so yes, there are roles, cluster roles, and you can tie those to users and tie those to namespaces. Now, a namespace here is a Kubernetes namespace. What that is effectively an administrative boundary within Kubernetes where you can say that resources, so various different objects, reside within a namespace, and there's isolation between those namespaces. So similar concept with different things. And effectively, you can then look to ring fence certain resources within that namespace, and you can do permissions based on that. So I could, for example, say I'm going to give permission to Bob to namespace 123, and he would be able to see the resources in there, assuming I tell him that he can edit them, he'd be able to edit them, but he wouldn't be able to do anything with the other namespaces unless I permit him to do that. So we have that level of control. But where cluster roles and cluster role bindings come into play is that you can actually say, well, I want somebody to have access to the entire cluster, so I won't namespace them, I will allow everything, and that's where the cluster admin role comes in. So as you can see from those descriptions, that's the cluster wide one, but the admin, the edit, and the view roles here would generally look to attribute those at more of a namespace level. But again, you can cluster if you need to. Just think about the reason for why you give someone access to everywhere rather than the specific namespace you actually want them to there. So I mentioned the mission controllers earlier. So this is a flow, as I've showed, where you can see authentication, authorization going through there. If you're interested in the mission controllers, there are two types of a mission controller. One's called a mutating, the other one's called a validating, where put the mission controller and they have weapons associated with them. A mutating one, you can actually say, I want you to change the object that's coming through to look like this. So if somebody says, I want you to add some additional labels to this resource, something like that, you could actually have a mission controller there that will inject those labels onto everything you're creating, because you always want that to be the case. And then the validating one is, again, that's the nightclub bouncer here. So this is the one that says, are you aligned with any policies that I need to check against? Should I let you into the cluster? So two things that can work there. You can use one or the other, or both of them, depending on what your use case is. So what I'm just showing you here is a couple of mission controllers, just because they're kind of more interesting ones to talk about from a security point of view. There are loads of mission controllers. Some of them are enabled by default, some of them you have to enable. There are lots of things doing their job under the covers, which you don't necessarily need to worry about from a non-security focus. But these are some of the really key ones when I'm, again, having discussions with people. These are the ones that I would look to bring up and really talk about with them. So pod security is an absolute key one. If there's anything that you take away from today and you're working with containers interested in how to deploy them securely, think about the pod security, the mission controller, and how that works. Now, it's admittedly a little bit of a weird one at the moment, because as you can see from the screen there, they deprecated it in the last version. However, there was a justified reason for that, and that is that the way it had been implemented was problematic. It wasn't simplistic to use, it wasn't as effective as it could be. There was too much learning involved to actually be able to use it effectively, and they need these things to be simple, and you should just be able to achieve them. So as I said, version 1.22 is the latest, got deprecated in the last version. But at the moment, a replacement is being worked on. I don't know exactly how far they've got. I think I provided a link to that in the end. If you're particularly interested in going to GitHub and having a read of all the justification of what their plans are from this point of view, there's a lot of interesting stuff in there if you're so inclined. Now, the idea, as you can see there from that third bullet, is that they're looking to replace it with a new way of doing things and building it around those pod security standards. Pod security standards, again, this isn't anything that's hidden. You type that in on Google, you will bring up the same web pages and you get the same table I'm showing you there. Okay. What they are trying to do is to say, how can we make it really easy for people to utilize security when they're dropping things into a cluster? So what they're saying is, right, well, let's come up with these three profiles. We'll have privilege, we'll have baseline, we'll have restricted. Privilege, you can effectively do whatever the hell you like on the cluster. Baseline, it's a good way of deploying it. It'll be used by most people. And then restricted is, actually, there's some really good security practice here. If you want to do things securely, this is the one you're going to want to target. Now, my point of view here again, bringing up OpenShift, is that OpenShift has a similar thing here. It's called security context constraints. And they have a number of different policies there. One of theirs, confusingly, is called restricted as well. But that is the one that is the default to be used when you're trying to bring stuff into the cluster. And that's really important because it's nicely boxed down, and you should try and make sure that everything you create can be deployed into that one. And again, it comes back to the education piece. If you can get your head around how things need to be configured to be deployed under these, you can start educating people and helping them when they're creating their containers to say, You're going to need to do this. If you don't do this, it won't be deployable under this policy. Therefore, it's going to fail. You're going to have to rework it, or it's not going to be a security candidate. So it's understanding that and sharing that with these people that you're then actually expecting to go and create this stuff. So, in terms of what this admission controller actually does, is it's all based around something called security context. So when you are configuring a workload, and by workload, what I mean here is how you're effectively going to get your images into the cluster. You can do it as something called a deployment, you can do it as a pod, you can do it as something called a stateful set, a daemon set. They're all different ways of how you want your containers to run the cluster and various different justifications for it. So within any of those workloads, you can define security context about how your container should run. Those contexts will cover the items that you see on this here. And what you can then ask this admission controller to do is you can set up effectively what answer they need to give you. Now the answers to most of these, for almost everything that you're going to want to run, unless you've got a specific use case for it, is I don't need that level of access. I don't need to be privileged. I don't need to be a root user. So you want to configure these things to say, I don't want, if you're going to be a root user, you cannot deploy under this profile. So I'm going to challenge you. I'm going to say, actually, let's think about what we're doing. So if you're spinning up a container, do you actually need to have access to the underlying host? Well, if you don't ask for it. So make sure you're configuring these things in a correct way. An interesting one just to pick out from that list is around the running of root and non-root containers and something called kernel capabilities. So kernel capabilities, if you search on Linux capabilities, is what you'll find when you Google it. They are the breaking down of all the permissions associated with a super user into distinct units that you can decide you will turn on or turn off. So you don't need to say you're a super user, have absolutely everything. What you can do, and this is a really great control around it, is that you can actually say, right, well, I do need to run as root. You might find, for example, there's an application that's out there that, for whatever reason, doesn't support running as a non-root user. But actually, I don't need to do anything special, or I need to do this one thing. I might need to, for example, for running a process, I might need to elevate my privilege to run that process. I might need to bypass a file user ID check on a file or something like that for a process. You can decide that actually you're just going to assign it that one capability to let it do that one thing, rather than giving it full super user privilege to absolutely do everything that you would be able to do on a standard computer if you were a root user. So that's a really key thing there, is that you can effectively look to meet it in the middle. You can decide that, okay, right, there is a reason for this, I'll let that go, but actually, can we still look at securing things and reducing the security threat here? And then there's some additional things there. You've got mandatory access control through the likes of ARM or SE Linux. So you can decide if you're going to employ that on your machine, or you want to use, set up the containers that be compatible with that. You can control the system calls through SecOps profiles. There's default ones applied with most container runtimes. And then you can also control which sysctls are available to be used. And this is about changing kernel parameters. So, for example, you might want to set, an example that I generally fall back to here is I was deploying SonyCube. SonyCube wants to use Elasticsearch. Elasticsearch wants to change some parameter, I think it's, I'm trying to think, was the number of files it's trying to read or something like that, to a very high number. And so to do that, it has to use a sysctl, which means that it then needs permission to do that. And so one of the things that I was actually looking at a while ago is how you can split it out to give something called an init container. A whole world of stuff out there with Kubernetes, so it's difficult to try and explain some of these things without trying to delve into all of that. But effectively, what I could do is give permission to a container that's spun up just before my SonyCube container, and that one made a settings change to the kernel parameters, and then it went because it had that additional privilege that actually SonyCube itself didn't need. So I could say, as part of this deployment, spin up this first container, make a change to the underlying kernel parameter, then bin off that container, and then run SonyCube over the top of it, which then has access to what it needs. So for that small window of time, something had an additional privilege, but I didn't need it the whole time for SonyCube, so got rid of that and then allowed SonyCube to run over the top. So there's lots of very clever stuff you can do in this area here. If you're serious about doing security when it comes to putting containers on Kubernetes, you've got to know how all this stuff works because there are so many fine-grained controls that you can put in place. I have any questions on any of that, Rob? Is that right?
Nothing from anyone else. I had a few, but I think we'll pick them up again, Matt.
Cool.
Yeah.
Can I ask a question about changing these, temporarily changing these securities? I understand normally we do it through SSH sessions.
Sorry for that.
Normally we do it through SSH. Normally
Through
we
SSH,
access
you say?
container through SSH.
Right, okay.
And do we have some sort of scripts or something like that which can do those changes and
So this is all done within Kubernetes. This is configuration of policies in Kubernetes. Okay. So you're effectively saying, here's a list of rules you must adhere to for this container to be allowed to be created. You will then say, I would like you to spin up my container, and here are its security requirements. And it's almost like a checklist exercise. Do you want to run as root? No, you don't. Okay, that's fine by me. Do you want to have privilege? No, you don't. That's fine by me. Okay, I'll let you come into being. I'll let you spin up. What you might do is come along and say, I do want to run as root, and then if you as that user doesn't have permission to deploy that container against that policy that says you can use root, so that will jump back, that privileged one, not every user is going to be allowed to deploy something underneath that. So that's that point of entry where you can say, no, you're not allowed it, but this is all done within Kubernetes. The configuration, when you're creating your workload, referred to as a manifest, for example, as a YAML file, and you specify your security context there, that's telling the runtime engine what it needs to add to your container. So that's how it's controlled against that abstraction for you. So if you need a certain capability, your runtime engine is going to supply that capability to your container. So there's no logging into your container and making these changes. Make sense?
Yeah.
So did have a question asking about how do the key areas of container security fit within the overall DevSecOps process or processes? So in terms of just the context of it fitting within the lifecycle, because you had a chart earlier, didn't you?
Yeah.
So maybe we could pick
Yeah. So these settings here will very much fit into deployment. Okay. But you've got to plan them in first because you've got to get that configuration in place. And that's why I was saying again, all of this stuff really traverses that whole life cycle. You've got to plan it in. This control point where these are actually going to be enforced is at deployment time. This is your last chance to stop something getting into the cluster that you don't want going there, that you've put these policies in place for. That's why it's really powerful.
Is it worth just mentioning about the automation side of the fact that typically you would want to automate even the deployment and setup?
Yeah, I will get that.
So, so that's what I'm saying. Maybe
I have got stuff on the DevSecOps piece here. I appreciate it. It's kind of front loaded with a load of stuff about the orchestrator, so I will get that.
Okay, great.
So try not to go over the time, but
No.
I've done a huge talking too much.
No, it's really good.
So resource control is another one. So it's all very well putting all those controls about how you want your container to run securely, but do we want to let our deployments run on a cluster and steal all the resources and stop everything else from running? Obviously, answer no. So how can we control this? There are two efficient controls that can come into play here. One called limit range, limit ranger, and resource quota. And they are basically ways of saying how much resource things should be allowed, so you can put that ring fence around it. My preference is to use resource quota because you can do it at the namespace level rather than limit ranger. You've got to do it on a per pod basis. You'll think about them in more detail. How much do I specifically want here? Whereas the resource quota one on a namespace basis, if you imagine you've got dev team 1, dev team 2 working in the same cluster with their own namespaces, I can say dev team 1, you've got this amount of resource to play with. Dev team 2, you've got this amount of resource to play with. Go and do whatever you like in your namespace. Now, if you spin things up and you try and request more resource than you've got, Kubernetes won't let you. It will say no, go and have another try. And this is done by declaring how much resource your machine, how much resource your deployment is going to request and its limit. Also, when you have spun things up, assuming that you fit into that quota at initiation time, if your deployment then for whatever reason starts to run away with itself from a memory point of view, it is going to be limited again by that quota, and that's what you'll sometimes see if you're having issues with a container. It will give you a message that you've got an out of memory killed event going on, and that's where it's actually killed it off because it was growing too high. So you put some nice controls there, and that way you're protecting the cluster as well. So if you go back to there's something called the CIA triad from a security perspective, so confidentiality, integrity, and availability. And that availability is the key one. You don't want something able to kill everything else off by starving of resource. We've also got secrets management. So within Kubernetes, when you're spinning your containers up, they might want to have access to a secret that they're going to use. You create secrets as objects. And the reason for this is that you don't want to create a secret in your container image, because if you do that, you're storing it in a code repository. Everyone gets to look at your secret, okay? So what you actually want to do is you want to write secrets as these objects within Kubernetes, and then look to utilize those when you are spinning a container up. You will tell it to utilize a secret by a certain name that will then go and get that from that object. But there are considerations here as well. When you store an object in Kubernetes, by default, things are not encrypted. They're base 64 encoded, but that's it. So you've then got an object sat inside a namespace, and as we know, hopefully from earlier, it made sense. You've got permissions based around RBAC to say people can look at what. So if you haven't locked down your permissions correctly, a human user or a service account can potentially say, I'd like to have access to that secret. It's within their rights to do so, but you haven't told them they can't, okay? So what you can do, I think it came in, it was back about 113 or something like that, they brought in encryption of etcd. And so you can actually say, right, I'm going to create my secrets, but I'm going to encrypt them. And that way you can make it so that not everybody can have a look at them. However, again, depending on how you've got your RBAC set up, you could still enable somebody to spin up a pod that then says, I'd like to get that secret injected into me, and then I'll have a look at it there. Okay, so you've got to think about how to control these things. So depending on the scale that you're working at, depending on the nature of how you want to look after these secrets, how you want to manage them, also you've got to then think about the keys and things like that. You may wish to separate the secrets out into the secrets vault. Okay, so you can actually host that. Could host it within Kubernetes, could host it outside, and then you use those permission controls that I was talking about earlier to actually inject secrets into your container when you're spinning them up. Okay, so there are multiple ways of achieving things depending on what your needs are and how security conscious you need to be. Auditing, nice easy slide here. Do you want to find out who, what, where, when? Right, well, configure auditing. That's it, really. There's auditing available, but another key thing here is think about what you're doing with those logs in that audit. Where are you shipping them and what are you doing? It's all very well collecting a load of logs, but if they just go and sit on a big pile and no one looks at them, what's the point? Okay, you need to have a process in place whereby somebody does something that's a bit naughty, you find out about it and you find out about it quickly. You've got the logs telling you that they did the bad thing, so see the log, do something about it. And also making sure that you're storing it somewhere that's separation view. You've got your cluster admins in Kubernetes. If you don't store your audit logs away from them somewhere, that cluster admin that might be the malicious actor here has now got access to the logs to go and cover their tracks. So think about separation. Also workload placement to consider. So going back to my favorite read at the moment, the 800.190 guidance, think about where you place containers and pods within a cluster. So it says here that you should run things of the same sensitivity on the same host. You should look to separate out. So this one, as an example, if you think back to a traditional 3-tier architecture, front end, web front end, your logic to your database, and also thinking back to what I said at the beginning about the fact that we haven't got that same isolation of virtual machines. These are running on the same kernel, same OS. Therefore, if you break out of your web application and you are running your database on that same node, that same host, could you move sideways, try and jump into the database and get access to the crown jewels? If it was on a different host, okay, you've escaped the container, you've got to a host, but you've got to find a mechanism of getting to another host and then trying to break into the database there. So it's just making that attacker's life a little bit more difficult. And this can be achieved with a couple of things available within Kubernetes: node selectors, taints and tolerations. Effectively, taints and tolerations is my preferred one here. You basically say, if you've got this certain toleration figures that's all based around labels, I will allow you to be deployed to me. So you might say worker nodes only allow applications that are marked as being front end and vice versa. Therefore, the database one would be allowed to be deployed to that set of worker nodes, so you can look to do separation now. Exposing services is another one to think about. So by default, pods, containers are not exposed to the outside world of Kubernetes. Everything inside Kubernetes can talk unless you've got it down. I'll touch on that in a minute. But you can expose them outside the cluster. You can do things called node ports, load balancers, ingress routes, and at that point you're making that service that sits in front of the pods and that collection of pods available to the outside world. Really key thing here is to have the justification for why you're doing it and understand that you are doing it and why. So who you're trying to expose this application to, does it need to be exposed? Why are you making it available outside the cluster? If you're running other services within the cluster that want to talk to it, that's one thing. But why are you making it available outside? Your database, for example, does somebody outside it need to be able to log into your database? Do they need to be able to access it? Why would you expose that there? And then it's thinking about, have I secured something that I'm exposing? It's traditional security around this. You know, have you locked down how you access it, log into it? Have you got the auditing around it, that kind of thing. But also, as I said, in terms of the really do you need to, an example would be, we've got a number of applications that we use for pipelines. So using literally OWASP suites, a dependency check, dependency track, things like that. And we use their persistent backends to store vulnerability information. And so when we're running a pipeline, we have containers of the pipeline that will interact with them. They can do that within the cluster. They talk through the services that connect these pods together. They don't need to open up the cluster and back in, so we don't need to expose it. But sometimes we need access to the user interface of these products. And we could expose them, but actually we can use port forwarding, which you can just run over your connection to the API, and I can get to my service, the pods behind it, over that link. So I will invoke port forwarding, and then I'll just set my browser to localhost, and I'll get to the user interface of that for the duration I want it. I haven't had to expose something permanently to everybody, so it's thinking about things like that. And obviously, presumably you're not just running this as some kind of dev cluster somewhere. TLS is just a given, wherever you are. Network policy is another key one here. So as I said, by default, things are all nice and open within Kubernetes. So if you don't got things going, your pods are permitted to try and talk to anything else within Kubernetes. So what you actually have to do is invoke something called network policies. And you configure those and you say what is allowed to talk to what. Do it on a namespace basis again. The key thing is on day one when you're doing it, and again, this is educating the team, speaking to people, lock it down, say nothing is allowed to talk to anything. And then somebody says, well, I need this to talk to this. You go, right, well, I'll add a rule that says you can talk. They're all additives. So start by locking it down and then add things in. Don't just say, well, it's a free for all and then try and work out why things are talking and shouldn't. Beyond that, you can go with a service mesh. This is a way of monitoring east-west traffic and controlling it. It's application layer aware, so you get a better level of control. You can say, for example, this HTTP flow, this certain verb is allowed to this certain path or that. Goodness that you can bring on top of it. And so if you're running production, it's useful there. Used for deployment strategies, you can direct flows one way or the other and filter on percentages and so on to where you want it to go as you're deploying a new service. Right, this is then when we get to the pipeline bit. I appreciate you going massively over time, people, and I'll just carry on talking to you kind of shut up. So, building containers, some best practices. Again, this is the list that I like to look at, but there are loads of lists out there that all look the same. They might have some additional ones, they might miss some of these off, but this is the bulk of what you want to be thinking about. So, the base image, and I'll show an example of a file later. A base image doesn't really mean anything to you here, but you are choosing that base image you're building your container from. Choose a trusted one, so decide what trusted means to you at the organization level. How do you want to achieve that process? What is trusted? And that can mean different things to different people. You might say going to Docker Hub and picking any image at random does not equate to a trusted image. I would agree with you, okay? So think about what does trusted mean to you? How are you going to have that process? What do you want to choose? Do you want to say, well, from this vendor, I trust them, versus going trusting what Bob has decided to upload to Docker on that day? Minimal image is important as well. This comes back to the bloating of things. Do you want to load of packages you've got no intention of using in a container? All those packages potentially will have vulnerabilities that you've now got to patch. That is an overhead on you. Now, a lot of these things are just common sense. Do you want to make your life easier? Yes, right, okay, we'll follow this. It's quite a straightforward way of doing things. A key one to know as well, and this again is something that you learn by getting involved in this, is how to reference images. So when you create an image, you can give it a tag. The common principle for tagging images is that you will give it a version number, but also you can give the same image a tag that says latest. And so everybody knows that they want the latest one. They can just say, I'll have this image, tag latest. The problem is that latest is going to change. So today, latest is version 1. But next week, latest could be version 10. I'm just using the same tag. I don't know that the versions have changed, okay? So it's having awareness of that. So refer to it by a version tag because they won't change that version. Or if they do, you can decide to go one better and you can use something called the image digest. And that is a hash of the container's contents. That is immutable. That cannot change. If you make a change to the content of the container, the hash is going to change. You have got that immutable one-to-one relationship. So you can reference it by its tag, or even better, you can go for a digest. And that's really important if you try and move a definite object through a pipeline, for example. Not running as root, absolutely key. Hopefully that's the bang on about that one. But what I will bang on about here, and you can interpret it whether you think it's a wise idea or not. If you don't specify a user in a container, it will run as root. The default is root in containers. Not good. Be aware of it. Make sure you've got things in place to counteract it. Upgrading packages in an image. Bearing in mind we're going for immutability here. If I update an image, if I update a package by just running yum update or apt update, apt upgrade, etc., do I know what I've just upgraded my package to? I can probably go and find out. I fully accept, do I want to interrogate and understand version of package X or Y or Z? I can do. But all I know is at the moment, all people should have to know is that they're using a particular image. They shouldn't have to know that I've then applied all raft of updates to packages within it without documenting. I've specifically gone from version 1 to version 2 of this package because I needed it. Now you take the image as it is. If you do find an image that you wish to use, but there are vulnerabilities with some of those packages, find out what version you need to do and actually run those upgrades on a per item basis, specifying the version. Give some documentation in your Docker file that says, I had to upgrade this one because it was vulnerable. The image doesn't yet, the upstream image doesn't yet have this package in it until you make a conscious decision. And that's what we find a lot here, is really understand why, justify why you're doing it. That includes secrets. Then we've got a bit about copy versus add. So you can run a commandless copy or a commandless add. The reason for not using add is that potentially, if you don't know what you are adding in, it can extract archives and potentially malicious code from wrong, whereas a copy won't do that. You can make a decision to then extract it. If you know what you're copying in, add is fine, but it does sometimes get flagged up in some of these container security tools. SSH not needed, don't include it unless you've got a purpose. And then you can also remove any of the set user IDs, set group ID permissions, or change permissions and how things run in the container. You don't need to get rid of. So this one here, hopefully you can see this clearly. A couple of these, this is effectively a Docker file, or it's a Docker file, not effectively. These are two separate Docker files I'm showing here. Okay, so the one on the right is not the way to do things. The one on the left is a better way of doing things. So you can see on the left, this first line here that you see on both of them, pointing to the line one that says from for anyone on Zoom, that's the base image. Okay, I want to create my container using that as the base image. Specifying latest on Python, I don't know what I'm getting. Specifying the other one, I know I'm getting Python 397 running now 0.314. I've got more information, I know what I'm running. What we then also do on the left-hand side one here is to actually create a user and specify that we are going to use that user and give it access to the things that we are copying over. Key thing when you're specifying a user as well, on that final line that you can see there where it says user and $UID, use the UID. And the reason for that is if you've got one of those permission controllers looking at what it's trying to let in, they don't know what the user ID of my user is. So you give it the user ID, say it's 1,000, and it can determine whether it's root or not. Just makes it a bit easier there. The one on the right-hand side, I'm running any old container from Python. I can go and find out what it is with a bit of work, but it's not particularly obvious to me. I'm copying all of those things in, and that container is going to run as root. Okay, so there are those are the differences there. Another thing that I mentioned earlier was around the bloating of images and how to try and counteract that. One of the things offered by Docker, again, if you go with Builder or Canico, where you can do the shrinking down to a single layer, a single snapshot, you don't need to necessarily worry. But this one here is a multi-stage build, and you can see it's split up into two sections shown by the hashes. So the first one, I'm saying from node 12.22.6, which is a bigger node image, as installer, I want to do these things. And basically what I'm saying is I want to install an application in there. And I'm going to use a load of build tools that are available within that image. But when I want to run it, I don't need all those build tools. So what I can actually do then is say, right, what I now want to do here, and this is the from node ending out pipeline. I actually want to use a new image, and this is a minimal image. We know it's minimal because it's Alpine. Alpine's a very small container operating system. I'm going to specify my users, and the important line is this copy line. Where it says copy from installer, installer is what I call my pod, my base image in the first section. So I'm copying from that the application that I just built, and that is all I'm copying in. So I could have put every man and his dog into that first container, into that first, the first container. But the only thing I'm going to copy is what I've specified there. So I can blow the rest of it away. I can have a smaller image, just what I need, and then I've just got to make sure the tools that I need, the package that I need for it to run, are in there. And again, specifying the user on that one. This is an example here of what I mentioned about these securing these workloads, specifying your security context. As you can see, middle of the page there, security context. They can be applied both at the pod level and containers, like I say, multiple containers in a pod, so you can have some stuff that applies at the pod level, but the container level takes precedent. We can see here, privilege, you want it to be true or false, and our privilege escalation, true or false, what use do you want to run as, what group you want to run as, so on and so forth. Capabilities, do you want to add anything, do you want to drop things, you can choose to drop all capabilities. So you can specify all of this stuff here and create templates for your team that are working on it. So this is how I want you to try and make it work. See if it does, if it doesn't, that's address why it doesn't. There might be some things that we need to have as an exception here. So you can build all that in, and then that will hopefully then be compatible with one of the emission controller policies that says, should I let this in? On to build, here's the pipeline for anyone that's desperate to see this. We front load. We should always front load these pipelines. We want to shift left, as Peter, I'm sure you will come across. We want to fail fast and we want to fix fast. If my application, testing over here, on the left-hand side application box, picks up that my code is not written in a secure way, or I've got a load of vulnerabilities in what I'm creating, I want a quality gate that says, let's just stop, let's not carry on, there's a problem here. Likewise, I want to check my base image, that blue box on the left-hand side that says contain base image, for the equivalent things at the container level. Is the configuration flawed? Has it got any vulnerabilities in it? If those two things are good, then it makes sense to then think about actually putting the application into the container, build it and put it in the container. It's also worth here, key thing is this built image container scan. Double scan what you are using. Scan the base image, make sure it was good to start using it. Scan the built image to make sure that everything that you put in there didn't introduce any vulnerabilities. Otherwise, you fail to do that check and there's now stuff in there that wouldn't be scanned. So that's really key. Deploy it into a runtime environment, do your runtime scanning. So in the security world, that would be dynamic application security testing. Put it in there. If it passes each way, we're then moving into different environments to production when you want to get there. As the note at the bottom says, it's very basic, but not trying to show every item of security. It's just trying to lay out the basics there. Also, images are moving through registries, so make sure that you are controlling access to them. Think about humans and programmatic users. Your pipeline is going to want to put an image into a registry so it needs access. Does a human need the same level of access to pull and push images out of that registry? Think about it across environments, okay? So you've got an image that goes into a dev environment. Should I be allowed to pull that image from there into my production environment and run that image? I've not tested it anywhere beyond the initial dev test. So put those controls in place that say, actually at each step of the way, you should only be allowed to take from a production registry into a production cluster, likewise a pre-prod registry into a pre-prod cluster and so on. Secure connections there, and also deal with stale images. So people are going to build lots and lots and lots over time, but if you're not going to use them, if you don't want people to use them, get rid of them. Okay, let's housekeep, let's tidy up our resources. Don't give people the opportunity to, by fault or through deciding to try and bypass something, they're going to use something that they shouldn't. So container security tool, lots of different tools out there. What I would say is, if you choose the right tool, you'll need one tool to do all of this for you. If you don't choose the right tool, right is probably the wrong word. If you don't choose a tool that has all of this capability, you can instead decide to stitch together 2, 5, 10 tools to do this. But you've then got to manage all of those tools, the overheads that go with them. I get a lot of conversations with colleagues and clients as well as to why should I spend some money on product XYZ that does all of this in one go when there is open source product 1, 2, 3 that can do something. So generally, and I've not got it in here, but I've got a diagram that shows all of the different stages across the life cycle. I'll draw a red box around maybe 10% of it and say that's what you're trying to put into place here. You're doing some container security, you're not doing all of it. You know, you're telling me that you are putting the most sensitive data in the world into this cluster, and yet you are looking to do 10% of the security that I would advise you should do. So being able to have that conversation, understanding what those products can offer. So if you've got a good security tool that can do end-to-end, so let's refer to it as an end-to-end security tool. That's the key thing here. It's across that life cycle, as you can see. On the developer's workstation, generally, you can give them an interface to that command tool, whereby they can actually scan on their local machine container that they are playing around with, or the base image they're planning on using. So before we've actually got to the pipeline, which is the second box at the bottom, that developer on their machine can go, oh, I'm planning on using this base image. Right, well, I'll scan it against that tool and make sure that it says actually it's worth going any further with it. They then decide to use that. They then build their container on their local machine, they have to play around. Right, we'll scan the thing that you just built as well. Get a view as to whether what you are building at the moment is any good. The way that I always think of it here is you're empowering the developer to look really good at their job. Because by the time it goes into the full pipeline that everybody's going to see, they've already had a chance to fix potentially 1,000 faults that occur because they didn't quite get things right, let's put it that way. Whereas if you don't give the developer that chance, the first time that they're going to test anything that's in the pipeline, when everyone's got visibility of it to see the 1,000 vulnerabilities that they tried to put into production, you can give them the chance to actually fix things really early. And then what we find in the pipeline is it's using exactly the same tool. So that command line interface that we're looking to use, that command line tool on the developer machine, we can actually build into our pipeline as well. So we just spin up the pipeline and use this functionality. When it comes to the formal testing, someone says, can you scan this image as part of these quality gates? We invoke exactly the same check. So the person who's the developer has just had a chance to do the same check informally on their machine. Then we get to the deployment phase, and this is what I've been talking about with these submission controllers. So this, like I say, it's your last chance to stop somebody bringing something into the cluster. You can build all these policies around it using the inbuilt admission controllers, and you can also utilize some of these end-to-end tools as well, provide their own admission controller. So where I've got all these policies in my security tool that says shouldn't run as root, shouldn't have vulnerabilities, all those kind of things. When I say go and create deployment 1, 2, 3, this line here is the admission controller that we've deployed into Kubernetes, not a default one that comes with the end-to-end tool. We deploy it into the cluster, and it goes back to the security tool, and it says, should I allow this deployment in? Has the image that's within this deployment got any vulnerabilities? No, it's rid of the vulnerability, and it'll go, right, well, I won't let it in. And that's it. You're not getting that deployment into that cluster. You have stopped it there. All of those vulnerabilities would have been flagged up here, so somebody should have dealt with it. Again, you show all your quality gates in place, but you're not going to allow it in for risk control. But let's assume that things get through, but also remember that not every single vulnerability exists at the time that you scan it as well. So some things will get deployed that don't have vulnerabilities on the day that you did deploy them, but eventually things do come about on their issue. And that's where the end-to-end security tools have, let's call it an agent, however you want it to. But effectively, it's equivalent of an agent deployed as a container into the cluster that can then look at the status of everything running in that cluster. It knows everything you've deployed, it knows all the images, and it can say, right, this vulnerability has come about, it's in that image, you're using that image here, I'm letting you know that you should probably do something about it. So you've got that full end-to-end life cycle monitoring through a container security tool. I've probably covered these, but very quickly then. So these are the kind of scans that you want to have in your security tool. So checking of the vulnerabilities, checking of the configuration. Okay, so are you configured securely? Do you have any vulnerabilities? It boils down to. The other thing to remember as well is that although we're talking here a lot about the actual deployments into the cluster, those aren't the only things that change in the cluster. Potentially there are configuration changes for the cluster that aren't workload related. So somebody might want to create a new role, they might want to create a new policy for an admission controller, they might want to deploy a new admission controller and so on. You've got to think about a process for actually controlling that those configuration changes. So you have a pipeline for your containers, but you also need to have a pipeline for the cluster configuration as well. and you need to think about how can you implement a system that can actually look at what should and shouldn't be allowed on those components you bring in. Now, I think from memory, the next slide is a little bit of a scary picture. This is effectively, for anyone that is aware of it, something called OPA, Open Policy Agent, and there's OPA Gatekeeper, which is a first-class citizen in the Kubernetes world of OPA, effectively. You can decide that you can take all of your controls that you need from a security point of view, all of these security requirements, filter anything relevant to containers, and then you can say, right, well, we're going to create policy as code, and that's a really key thing to look at from a cluster point of view as well. So you can define all of these policies that state how your resource, how these objects going into the cluster must be configured, what they must adhere to. Should they have a certain label? Should they have a resource on them? Should they be at this type, that kind of thing? And what you can do is then when you're running through a pipeline where you've got your resource channels, you can see in the development box, is that you can actually validate whether that resource is compliant with where you want it to be. Now, this diagram here is showing going through a GitOps model, which is basically whereby you put everything into that config repo, and then your GitOps tool of choice is going to make your cluster look like the repo does from a configuration point of view. If anything starts to drift in the cluster, it's going to bring it back in line with what you've got stored. So your entire cluster configuration is stored as code. I won't drop it, I won't go into massive detail on this one, but that is a really interesting part of how you can manage your cluster configuration and look down the GitOps route. So in terms of deployment, I've hopefully banged on enough about deployment so that you guys appreciate this is your final chance to stop things going, okay? So it's doing all those checks. Are you trying to run as root? Are you trying to do this? Having specified this. Also think about maybe you want to say, is the image signed by the right person? So you can do image signing and you can do put image checks in place via permission control here. You might also wish to say, I only want people to be allowed to deploy images from a certain registry in, so put policies in place, then say only from this registry can you deploy an image. So your production registry, you don't want somebody going off and getting an image from, for example. That's your production cluster. So, summary of that section. Plan security in, make sure you've got those 5 areas covered that I mentioned earlier. So the image, the registry, the orchestration, the host, the containers. Shift left as much as you can, give those developers a chance to look really good. Deployment, last chance to stop things, but you've also got the runtime element as well. You've got to know what's going on in the ongoing security state of your cluster. This is the final section, it's shorter. Apologies for anyone that thinks I'm banging on forever. So runtime security, you've hopefully achieved loads of really good security through your pipeline, through your planning. You've got yourself a nice cluster and you're building things in a secure way. We've got to make sure that we are doing that segregation I mentioned. So with the same purpose and sensitivity, you might also want to segregate privilege versus non-privilege. So where I was saying, sometimes you've got to spin something up that does need privilege for whatever reason. You might then say, right, well, that can work on these nodes, but actually something over here, I don't want anywhere near those nodes. I don't want to risk that privilege has allowed that person, allow somebody to get out and go do something they shouldn't. Having the namespace, having the resource requests and limits in there and those quotes is good, and then making sure we have control of the network as well. And then going back to that end-to-end security tool, the good ones will monitor your cluster to a nice level, okay? So they can look at the compliance of your cluster. So a lot of the end-to-end tools now will actually be able to say whether you are compliant against NIST and Docker and Kubernetes benchmarks and so on, and tell you how you're configured against those. We'll be able to point out where changes will need to be made. And monitoring workloads is a really important one here. So one of the tools that I'm working with at the moment, again, this is again, Red Hat tracker thing, but something called Red Hat Advanced Security, was based on the StackBox effectively, which Red Hat acquired. But the likes of Prisma and Aqua and Sysdig, they all work, so I'm not trying to name shit one rather than the other. On ACS, what we're using at the moment, what we are getting here is that we can actually look at everything that we're running. So it's got that full view of the entire cluster. It knows and it can tell me about every single deployment. It knows every image in every deployment, and it can tell me and give me a real-time view of that. When a new vulnerability comes in, it will tell me that this vulnerability exists in all of these 70% of images that I'm using, even if they're different images, different names, because they've got a shared component within them. because they're all based on a certain base image. It will tell me all of these are going to be impacted by this. If you can fix this, if you can then roll that change up, you're going to fix the vulnerability in all of these. So it gives you a nice view there. It can also monitor interactions with the API, so it's also monitoring Kubernetes, things that are going on in there as well. There's something trying to communicate with the API, kind of flag that up, so you can monitor that, create rules and policies that say what interaction should be permitted. But the processes and containers is an interesting one here. So it will actually understand everything that is going on within that container. It's got the visibility, it's got this equivalent of an agent that's even set installed on the host. It can see everything that's going on that host. It can tell you within that container, I can see these five processes running. Now, in the ACS product and Advanced Cluster Security, what it will do is it will learn a baseline for that container over a period. You can then decide that you want to lock that baseline and say, if you see anything deviate from this, I want you to flag it up to me. But the thing that I think is quite cool in here is that it can actually, yes, slides will absolutely be made available. To go further than that, what it can do is you can actually have it kill the pods. So an activity occurs within that pod that doesn't fit the baseline that you have developed for it. It'll go, this is wrong, something is happening here that shouldn't, I'm going to kill that pod, and that container is gone at that point. Now, I've actually been discussing this recently in some client meetings and trying to then have to say, yes, it might kill it off. If you haven't created any other pods, so if you're not running highly available, yes, it could be an issue if you've got one pod, because it is going to kill it, that service will be unavailable. Deploy everything highly available, etc., etc. It will just kill off the one pod that had a problem rather than 10 pods that are running as a unit. But also, that isn't the end of it. Just because it's killed a pod, somebody still did something, okay? Somebody still got to that pod and made that activity happen. So you've got to make sure, again, that you've got that team and that process in place to actually go and investigate that, because otherwise that person is likely to find exactly the same route in, because you haven't fixed the root of it. All you've done is that whenever they try that activity, they're going to get, the pod's going to get killed and it's going to stop them in their tracks. But they might come in and not do that same process. They might come in and try and find something else to bypass. And again, hopefully the baseline should stop this, but make sure you deal with the source of the problem as well. How was somebody able to get this far to do this for that to be the problem issue? Okay, so in summary, and I think this is the final summary of everything, think about the best practices across those areas. And I probably should have included plan on here, because that's a really key thing. You've got to plan ahead actually how you're going to build and implement a secure system. But thinking about in development, how are you going to get a secure container image and containers? When you're building, what checks can you put in place to make sure that you are invoking every formal check that you should do on that, so you can get the best out of your pipelines? The deployment side of things, again, it's our last chance to control things, and you can write some nice policies there that say whether things should be allowed with privilege or not. And then runtime is monitoring what's going on. You've got to see what is in your cluster. You've got to have that view of the landscape. And ideally, a good tool there will really empower you to understand what's going on and take the appropriate actions. And then just to really reiterate that one, this is everything that I told you at the beginning. Hopefully that has all resonated throughout what I've said. Educate that team. That's the really absolutely the key thing here. Go and tell other people how to do this securely when you are aware of how to do so and confident you can describe it to them. But it's all those things I told you. It's the workload objects, it's the containers, it's the runtime, it's looking at the vulnerability. It's all that good practice to build together to make sure that people know how to and why as well is more important here. You've got to make sure that people actually understand the benefits that are going to come their way from doing it. That's page of links. I appreciate there's a few on there. I've tried to cover various different things. There's lots of good material out there, but hopefully when the slide deck's shared, you'll have those in a way that you don't have to write 1,000 characters to go and find it.
Brilliant. Okay, thank you very much for going through that. Let's just thank Matt in the usual way. Please don't worry about going on a little bit longer than you maybe anticipated. It's been really good. So the content's great. Does anyone in the room have any questions that you wanted to raise with Matt? I've got a few here, but if anyone here is, first of all.
Sounds like.
No, that's okay. Well,
I appreciate I told you a lot of stuff.
Yeah, that's right. There's been a lot to take in, which is great. So let me just there's a couple of questions that I just made a note of. So you may have covered these as you went through. So first of all, do containers need to be based on Linux?
No, so you can run both Windows and Linux containers, and you can do that within the confines of Kubernetes. What you will need is to have the correct underlying host, so you potentially will need Windows and Linux hosts within your cluster.
Okay, thank you. Have there been any exploits where it's been possible to break into another container that's running alongside one that you're aware of?
I'm not aware of, but absolutely there will have been.
Yeah. Okay. And this might be going through people's minds because the amount of information you put up here is huge, which is, are there any sort of, where would people start? I mean, you've given us a list here. Are there any shortcuts that people could start with if they're starting out on this journey with containers to perhaps get some guide rails in place so that they can start to do some development work in a fairly secure way? And if they went too far and turned all of the controls on, would something bad happen?
So I think in terms of where to start, my focus would be around building secure container images, because I think once you've got your head around that, and in conjunction with that, it's going to be that mission control piece as well, so those security contexts that are on the deployment piece alongside it. But understanding that you want to build a secure container and there is a better way of doing it than just, I'm going to throw stuff on a page and see what happens, is certainly a massive part of the initial battle. And it's then understanding how you can use some of those controls. The initial control thing is this security policy piece in conjunction with it. I would say try and get things deployed and just play around with, can I get this to be deployed under the most restrictive policy that there is? And you know, a lot of the time, the first time you try it, it's not going to work because you might not have enabled a permission on a file system, things like that. But that was one of the ways that I really found I could learn this, because I would say, right, as painful as it is here, I'm not going to allow myself to try and cheat, because then I have to learn, right, well, okay, that didn't work, but do the logs tell me something? Does it say I'm trying to access this? I can't. Okay, well, if it is, how can I go and put something in the container? What changes can I make to then say, actually, yeah, it can be deployed, and it's in that way. We've had it with a lot of things when we started building our pipelines, and we'll go and get a lot of the public images and the public configurations for Kubernetes. They aren't there to be locked down. They are there to work, because that's what people want their products to be able to be dropped into your cluster without issues. So we have then had a policy of, right, we're going to try and convert all of these to run the most restricted, and you learn a hell of a lot through doing that, because you've got to really dissect each step of the way to get it running.
Okay, you're mentioning public repositories.
Yes.
Are there any safe places to go where you've got pre-tested, verified containers that people can use without worrying and having sleepless nights?
So the Docker Hub, although I have mentioned it a few times in reference about you might not necessarily just want to go and grab any old image from there, there is the Docker trusted content effectively. There's a setting that you can apply with Docker to say only show me trusted content, but also there are trusted vendors on Docker Hub as well. I can't remember exactly how you would find them out, but yeah, effectively there are some that are vetted, whereas others won't have been. So look for the what looks like a professional body. If you are going to go and grab a container from any old topic or Harry, you've got to have that awareness of this might not necessarily be what it says on the tin. So I would say that would be very caution. So in those ones.
Okay, and then finally, if people want to look for complementary tools, like you mentioned the need to analyze logs, and you mentioned a couple of security tools, where can they go for information to maybe compare and contrast different tools? Because it sounds like there's a lot out there.
Yes, there is. Where to go to compare them? That's a really tricky one. So doing the job that I do, we will ask vendors for their data sheets on their products. And as you can probably imagine, every vendor that I go to will tell me that their product is 110% better than everybody else's, because it's so wonderful and does everything that the others don't. And they will all contradict each other. So it's a bit of a minefield there. you can look for articles that people have posted where they have done some investigation around features in terms of finding the end-to-end security tools, for example. The kind of top players in that area are the likes of Prisma Cloud Compute, System Secure, Aquasec, the Red Hat ACS is up there as well. And then you've got some of the open source products that might not necessarily do full end-to-end, but you've got things like Claire and products like that that will offer a subset of those features. So really understand what they are going to give you rather than saying that's container security done, tick that box.
So might some of those open source tools be good places for people to start to learn?
Yes, absolutely, yes.
Yeah.
And this is one of the great things now about how the open source movement has really exploded. There are so many products out there, but you know, if you type in prefix anything generally with GitHub and container scanning or something like that, it's going to tell you the 10 repos of things that people have created. Absolutely, go and have a play around those things. They're nice and easy to access, and you don't have to pay to use.
Okay, we have a question from Thomas Cope on Zoom. He said, I guess good WAF in front of the container can help you find that exploits. So help you find that an exploit is trying to break out. I might not have got the sense of that right.
I know what it means, and hello to Tom, I know Tom.
Great.
So yes, absolutely. And as with everything in security, the key mantra is always defense and depth. It is layering your security. So yes, if you were to put a web application firewall in front of your cluster and you have then the ability to monitor what's going through there, configure policies to catch certain traffic and stop it and so on, you can absolutely layer that and ideally protect it there. Yes, if you can protect things at the boundary and stop the traffic ever even getting in, absolutely, you've got a budget to do so. That's something you can build on top.
Yeah, thank you. Yeah. And then a question from Pandora who says, do you think we'll see more of an investment in container security as more developers start to use containers and we start to see more creative exploits being used?
I really hope so. As I said, I find containers fascinating. I think what they can offer is that ability to quickly spin something up and package it up and know when you have decided you're done with it and blow it away, it's not had any impact on the system. There's no residual there. It's not like having to put things in place to spin up a virtual machine and things like that. I think what we need to see is adoption within organisations, and we're seeing the banking sector, we're seeing the public sector moving and embracing containers. And as these sectors do it, there is going to need to be that investment there because they are going to want that security reassurance that actually what they are doing is running in a secure way.
So if you're spinning up a container, doing something and then disappear it, how do you audit that kind of thing? Where does the audit take place?
When you say disappear, do you mean me make it disappear, me tell it to be killed or to finish?
Yeah, you're saying you spin up a container, you do stuff, and then it goes away. Is there any evidence of that for audit? And
Yes,
what
absolutely.
you spin up is.
Yeah, so when I say make it go away, I would actually be there saying, I don't want this anymore, right? You can stop existing. You will also have some situations whereby containers fail to disappear that way, but would then be replaced. But all of that within Kubernetes, every action that I take against the API, so when I'm saying I want this deployment to occur, which has these containers within it, that is all going to the API, which is audited. And so all of that information is recorded. You can choose whether you are just recording the action that you are taking. So on this day at this time, Matt said, please create this pod. But you can also have it go one step further, which is actually to record all the payload as well. So I could have it record every single bit of that configuration that I'm saying, can you create this pod, it's this. Now, in terms of the pod dying, you would effectively get events within the cluster, and you would have a tracking of those. I'm not sure off the top of my head, but I don't think it would come out as an audit event, but you would have the monitoring within the cluster to say that has disappeared. But you don't really necessarily care that the container died and it then came back. That's just part of it running. It's you want to more find out from a why did it die? Was it a functional issue with the container? So you'd be looking at more the application kind of side of logs going to
And the output, where not just the, what do you call a shell,
Yes.
which maybe is meaningless per se, other than why it died, but then what was in there, and that the stuff that in it is what you would be on.
Yes, and you want, and again, a really important thing is to make sure that your application, your container logs everything that you are going to need to know about, because the idea is you don't really have to jump into I know it's told me everything it was doing at that time. I can go back to the 5 minutes ago when it died and see what those events were that were occurring.
So a question about container hardening, not the Kubernetes configuration. It is unlikely there is a one-to-one correlation between scanning and your customized hardening. Is there a way of something equivalent of a unit testing your hardening?
So, well, your hardening effectively of the container is related to the configuration in your Docker container file. So the security tools that are out there, if they've got the right functionality within them, will actually be able to look and analyze that container file and tell you, I can see that you've decided not to specify a user here, it's going to run as root, or you're using this command, or you're not following these practices. And you can write the policies that you then wanted to check against that Docker file to tell you whether there is or isn't an issue with it. So you probably go down that route, and again, it's all those best practice layers together using that image, not adding additional things in there. Because you're effectively, in the end of things, you're just running a process on that underlying host itself. You're not running a host. It's a process that's going to run on the underlying way. So,
do you have like a war story, an example of when an end-to-end security tool over Kubernetes has actually mitigated some sort of security risk in the real world? An anecdote, or maybe from a client which you can reveal.
No, I don't think I actually have seen anything.
Because it adds quite a layer of complexity, or every configuration adds complexity, and the other side of complexity is having like downtime from a configuration error.
Yeah, I'll just pretend that all my security is so good. I think got through it. No, I don't have a story.
Okay, thank you. Anything else? Okay, well, thanks very much, and we'll thank you again, Matt. Wrap up, and just to say thank you. So just to say thanks very much again to Matt. That was a huge amount of information there. He promises going to give us the slides so we can share those, and see if we can get recording as well for people who couldn't make it. For next month, we do have a topic. We haven't publicised it yet, but we will be doing so very soon. It's around an introduction to DevSecOps. So rather than sort of assuming everyone knows all about what DevSecOps is, or even DevOps or the security side, and why they fit together, Andrew Harley, the chair of the group, is going to be providing a taster for people just to sort of set the scene for that. But also, I'm sure it'll be good for people who already know a little bit about it to to test your knowledge and learn and understand how how different people think DevSecOps operates and so forth. So that's on the 18th of November. I think that's a Thursday. That will be here and online again. So please, if you can come, if you want to do that in person, that's great. Otherwise, online, you're very welcome again. So we'll hope to see you next month. Thank you.
Thank you.